All right, good morning, folks. Welcome to the Tuesday, January 7th, 2020 Working Group Component Standard Office Hours. Happy New Year, everyone. As usual, this is our hour for folks to drop in, ask questions, get help with things that they're working on, whatever they need. So welcome, everyone. Happy New Year.
Hello, Happy New Year.
So let's just jump in. Whoever wants to go first.
Can you hear me?
Yes.
All right. Yeah, so like over Christmas and stuff, I was going through the Cube Control Manager CLI kind of like parsing stuff. And I took some notes and just, maybe just want to go through it again with you, just like talk through it and just see that I understood everything correctly.
Okay.
Okay. So should I share my screen maybe, or?
You can share your screen. Yeah.
One sec. Come on, Zoom. How does it work? Oh, yeah, here we go. Wait, I just upgraded to Catalina. I have to enable all kinds of stuff.
Oh yeah, I did that like a month ago.
Oh God.
Makes you authorize everything. I love it that it does that.
Yeah, I mean, yeah, it's a bit annoying in the beginning, but I guess it's better, right?
Good feature.
Yeah. I think I have to restart Zoom though. It tells me. Be right back.
Oh, to share your screen. All right, see you in a minute.
All right. This looks good now.
All right.
Cool. All right. So we are in new Cube Controller Manager command, and the first thing it does, it creates an options kind of struct, and I think this is very similar to what you described in the document as the kubelet flags struct, right?
I think this might be closer to like kube proxy. Kubelet does it like in a way simpler way than controller manager does. So be wary of assuming that.
Yeah, I was like,
I think the options stuff holds like, I might be munging this wrong, but I think it holds like both the configuration and some like runtime structures as well.
I'm not sure, to be honest. Wait, let's. I think these are like all the configuration things for the controllers.
Okay.
And there's also some like flag logic, and then basically it returns like there's a flag set for each controller, I think. And
okay,
then
so we have an add flags for each.
Yeah, and then there's an apply to, and at the end it's just like one big config which gets populated from those options, I think. And also does validation, I guess.
I see. Okay.
Yeah.
So the options are the command line options coming in, and then they have a custom function to apply that to the configuration as opposed to registering the flags directly on the configuration.
Yeah, so we're getting all the like component configs here, right, from like the version ones.
Yes.
And then we're basically using those as, I guess, defaults for like populating this option struct.
Mm. Oh, that's interesting. What is component config in this? That's the config struct?
That is the config struct, yeah.
I see. What does new default component config do?
It basically gets the version 1, I guess defaults it.
Okay. And then converts it to the internal. Okay. And then it's also setting a value for this port.
Yep.
Like, it's interesting that that is there as opposed to in the defaulting logic for that v1 alpha 1 external type. So like during there should be like like similar to the kubelet, there should be like a defaults function in the directory that defines that external type.
Isn't it like this function or?
It's indirect. There's like another place where defaulting functions get registered for specific versions of types. Let me see if I can find that. 1 second. Gotta connect to my workstation here.
I think it's like if I'm looking at like staging and Kube Controller Manager, there's no defaulting, I think, is there? Like if we
maybe there's not. Maybe it's missing, and we need to actually add it. I don't know. Let me see if I can find add folder to workspace. Okay, let's do. So like for kubelet, it's in package kubelet APIs config v1 beta 1 defaults.go.
Oh, it's in package.
There's like set defaults underscore kubelet configuration.
That's generated, right?
It's not generated. It is, and maybe the stub is generated when you first set it up, but it's handwritten, and this is where all the defaults are set for kubelet configuration.
Is it this one? No, it's you mentioned a different one, right?
That's the one.
That's the one, right?
Yeah.
What's the difference between why is this in package kubelet and not in staging?
Because the only thing in staging is the struct definition right now. That I'm not sure if that needs to change, but that we followed the convention of all the other types that were being exported from staging, which were only exporting their struct definitions, not their defaulting logic. So then, as maybe that will need to change in the future as more tools depend on them. But that's not the case right now.
They have a like controller does have a defaults as well. If we look for port,
There's one in Cloud Controller Manager for sure, but that's not our thing. VDM has a bunch. I just grepped for set defaults underscore, and I'm looking through what comes up. So the APIs. Let me do this with.
Yeah, it says like generic defaults, like generic controller manager defaults, but it doesn't say anything about like the port, which is set here. It's interesting.
Yeah. Interesting. There's all the subcontrollers have the files, but they have comments in them, like package controller stateful set config v1 alpha 1, for example. And then they have some of them have these like recommended default functions, like recommended default stateful set controller configuration. Defaults a pointer to a stateful set controller configuration struct. This will set the recommended default values, but they may be subject to change between API versions. This function is intentionally not registered in the scheme as a normal set defaults underscore foo function to allow consumers of this type to set whatever defaults for their embedded configs. Forcing consumers to use these defaults would be problematic, as defaulting in the scheme is done as part of the conversion, and there would be no easy way to opt out. Instead, if you want to use this defaulting method, run it in your wrapper. So maybe this is being consumed, and maybe they just weren't sure how it was going to be consumed. They didn't want to force that. I think as we figure out how to like subdivide the configs for all these subcontrollers, once we've kind of formalized maybe API groups for each or something, then because we'll be able to like say this is the stable thing that defines how this works, that flexibility won't be required anymore. And we can just put the defaults in the standard place.
Yeah. Okay.
Yeah, I'm not sure I understand the history of like why this is this way.
Yeah.
But Stefan might know.
Yeah, I might have to dig into this. Well, I wrote it down so I can trace it. Okay. Where were we? So let's see. So getting the component config. At this point, this is converted to the internal API, right? And then we're basically from that, we're populating this option struct, right? Which
so they're using the values from it. So what's goofy is that it's almost seems like there's an expectation that it was defaulted as part of that conversion, or maybe they called the default on it. Maybe, I can't remember, in the new default function. So we have to figure out, like, they're setting daemon set controller here, right? So let me pull that one up.
This one?
Yeah. But they're setting it from the component config. So like finding the thing that supposedly defaults that. So like package controller daemon config v1 alpha 1 defaults.go, right? It's like the same thing where there's no like a registered defaulting function. There's just this recommended one. So where is, oh, what are you in now?
That is the defaults.go, so controller APIs, v1 alpha 1.
Alpha 1 defaults, okay.
But that's the one with the, where all the recommended ones get called.
I see.
Set defaults.
Big v1 alpha 1. View controller manager configuration. I see. So they're setting. Okay, so then this is the defaulting logic that gets called as part of that conversion. And they're using all the recommended ones. And then they have a couple things here, the client connection QPS and burst that are overriding the recommended defaults.
But at which point does this actually get called, this function?
This
like
gets called as, I think it's part of that new default component configuration call. So if you go back to where you were before.
Like here?
Yeah, where it says scheme.default.
Okay.
I think that's where that's happening. If you go to,
it's like registered into the scheme, I guess.
Yeah.
The function itself.
Yeah, so if you look at package controller APIs config v1 alpha 1 register.go, there's an init in that file that registers add defaulting funcs. So it's local scheme builder.register add defaulting funcs. And then add defaulting funcs is in.
Yeah, and then it calls basically this one here.
Yeah, which calls register defaults scheme and register defaults, wherever that is.
Yeah, that's, and that it then gets called all the way down. Yeah. Okay.
Where's this register defaults call? I'm trying to dig through this, but I don't know where this register defaults thing is.
This one? It's it's easily generated.
So okay, so that's generated. So if you name something set defaults underscore foo, it goes into the generated code. I see. Okay.
All right. So let's go back where we were. All right, so the defaulting happens here, right?
Yes.
At this point, and then we have like defaulted options, like a struct for every controller.
Yes.
And there's some more fields being set here, I guess. And it returns the option struct. And so like at this point, we will have the expected defaults, which we define from the external API, like in the internal. And then like the whole flag thing happens, right? We create a flag set from the Cobra command. Now, if I see this correctly, this flag set is empty at this point, right? There's like no flags registered, I guess.
Not necessary. Is that inside the run funct, or is that? Oh, that's right. Oh, it's outside the run. Okay. So yeah, there shouldn't be any unless they're done in this scope. Because that command hasn't been exported in any other scope yet.
Yeah.
So.
And so this one is empty, and then we create a flag set for the controllers, right? And this gets created from the option struct we did. So we call flags on it, and then I guess for the controllers.
Flag sets. Okay. And, okay, so then they call add flags. So that returns a flag set with all of the flags registered on it, and they all point into Kube Controller Manager options.
Mm-hmm.
In theory, they all point into Kube Controller Manager options.
I guess so. I don't know. Like if we follow this, right,
they should. There's no guarantee that somebody didn't like throw a random global flag in there. I suspect they didn't, but because I think Stefan was working on it, I don't think he would have done that. But
so like yeah, this. So we have the options here, right? And those are like they're like added to, I guess, the options. Like if we follow this, like all the flags for the different controller, I guess.
Yeah, that seems to be the pattern.
Yeah.
They all end up on options. It's a relatively clean pattern.
Now, what I don't understand is at which point do they actually get parsed?
There's a parse function on flag set, so you could see if that is getting called. There may also be a way to just run the command that implicitly triggers the parse. I remember from when I was doing the kubelet flag stuff that Cobra has like a lot of implicit things that will trigger a flag parse. I just can't remember. So you might want to trace where this command is returned to.
This one here?
Yeah, it's probably in like a main file, for like a main.go file, or pretty close to where main is defined.
Let's see. No, not this one. This, I think, is generated. It's here, right?
Yes. Command.execute probably parses them. That's going to be.
This is in Cobra.
Yeah. Yeah.
Here, pause flags, huh?
Yeah.
Okay.
Well, we had to do some stuff in Kubelet to kind of work around Cobra, so just keep that. It's all in that version component configuration.
Yeah.
Doc. So keep that in mind. You may not have to do it. Like if you can get away with forcing people to choose between using all flags or all config, and you can move it all inside of one release cycle, you can get away with not doing the sort of backwards compatibility interleave thing. But the more options you have to deal with, the harder it gets to.
Looks like a lot of options to deal with.
So that was one of the things that we were looking at, like maybe legacy flag would make it easier to implement that sort of interleaved thing. But they seem to have a pretty clear mapping from each option onto the config field, and they have like separate memory for each. So it may be easier to implement that. Like with the kubelet, the problem was we were registering the flags directly on the config. So if we wanted to like load a config from a file and then overlay the flag values on that config to like support the backwards compatibility, you had to parse the command line twice, because you had to parse it once so you could get the path to the config file, and then you had to register the flags on the struct that was loaded from that config file, and then you had to parse it again so that values would be correctly parsed and written into that config file. But then there were all kinds of problems with that. Like you had to you didn't want to reparse global flags that were like outside of that, outside of the config, but still had to be on the flag set, because that might like mess up how they were parsed originally. Like some flags are accumulators, like so like every time you invoke the flag, it adds value to a list instead of replacing the value. So you didn't want to like end up with duplicates by parsing it twice. Like some things might affect global behavior, like logging that's already set up, and you don't want to screw with that. So we did all this goofy stuff to like generate a flag set that had all the global flags on it, but they all pointed to like no op storage, and so they would Cobra would or pflag would think it was parsing them, and so it wouldn't like complain that there was an unrecognized flag on the command line, but it also wouldn't mutate anything that had already been done globally. So we have these goofy workarounds. Here it looks like things are a little more isolated because flags are registered on this options struct, and then there's manual mapping and apply functions that maps it onto the config. So it may be easier for you to keep things separate here and like only parse the command line once at start, and you'll get all the options. And then if you need to load a config file and overlay flags on it, you already have that data in options, and you already have the apply functions that you can call to do the overlay. So you might not need to parse it twice. Case, just because there's a cleaner separation in this architecture.
Yeah. And the idea is we basically load the config file, and then we apply the flags to that config file basically. So the flags take precedence anyway.
Yeah, and the reason to do that is so like across an upgrade, if somebody had previously set a flag on the command line, it continues to like apply to the new location. Like if you had something in version 1 that was just a flag and not in the config file, and so somebody has the config file set, and they also have this flag set because that was the only way to get that combination of options. And then in version 2, we've exposed the same option in the config file as well, but because of the deprecation policy, the flag has to continue working too. So we need to make sure that value from the flag like is plumbed to wherever that config file is plumbed, so that anything trying to use that value in that location gets the correct value, which is the one that was being set by the flag, not like the default one that would come in from the config file being loaded without the thing being set in it. So that's why we do that. It might be easier to do here than it was in Kubelet because they already have this pattern that more cleanly separates the reading in of the flags from the reading in of the configuration.
So like if the flags get parsed on execute, like this basically like before we enter this like run block, those would already be parsed, right? I guess.
Before we enter run, yeah, if execute's parsing them, yes.
Okay.
And if you can, so here's the nice thing. If you can, if this architecture like basically has a clean enough separation that we never have to reparse the command line already, then you also don't have to do all the goofy stuff to work around Cobra that we had to do in Kubelet. I'm pretty sure you don't, at least to start. There might be another reason you would, which is around third-party libraries registering flags in the global flag set, because Cobra will, I think, try and pull in the global flag set.
There are like 3 functions here, I think, which do like global things. So we add like a global flag set here, and then we're adding global flags, which is like klog and like log stuff, right? And help. basically.
Yes. I need to go back and look at my doc on the kubelet, but I remember there was a problem where if we let Cobra parse the flags instead of calling parse directly ourselves, we had third-party libraries, some set of third-party libraries that had all registered global flags on the global flag set. So like the flags dot command line or whatever it's called. If we only wanted a subset of those flags and we'd only registered that subset with like a function like register legacy global flags with our flag set, when we asked Cobra to parse the command line, it would still go out and grab like flags.command line or whatever it's called, the global one, and add that to the flag set that was on the command before parsing. And so those flags would still end up getting registered, even though we hadn't manually registered them because it was part of the implicit behavior. And I think the reason it does that is because, like, you know, if maybe you expect to be parsing all the command line flags, including the globals, and this command only has command.flags on it, so Cobra is trying to like help you. But in our case, it adds implicit behavior that doesn't help us. So that was something we did have to work around. I think that's like a sort of a separate problem from getting to component config, but it is another problem that is important to control because vendoring new code can change our command line API, and we should maintain control of that. It shouldn't be just down to like a random dependency getting vendored in. Most people won't see that when it gets vendored in because they're not running like the help and diffing it against the old help in every PR. Maybe we should have a test for that.
All right. And then in run, we're basically creating the kubecontroller config from that option struct, right? At the end, I think we're calling apply to. So it applies all the options here from the struct to the config struct here.
What is this in?
This is in
config returns a controller manager config objective.
This is basically in the run function, right?
This is in the run function.
Yeah, okay. This is run. So we're like printing flags, and we create a config, which is then basically executed this completed config. I don't understand like the step of this one here, like why completing the config, like we're doing the bearer token thing here, but I guess it kind of like checks it or something and then it gets one right.
That's interesting. I think there might be other uses of complete that have like more detail that maybe would inform why it has that. What is in this complete again? Let's look at that again. Let's see. So authorized client bearer token. It's just a call. Interesting. What does that do? Are these like runtime structures, not serializable configuration? It may be that complete is there to like read stuff out of the config and set up some runtime structures that hang off of this.
It might be. I don't know. Fills in any fields that are not set. It's mutating the receiver.
Yeah, it also says it mutates the receiver, so I don't know.
What is meant by that? It's mutating the receiver.
It's mutating C.
Ah, okay.
Yeah.
This receiver.
That's the receiver. Okay. Yeah. Yeah.
What do you mean when you say like runtime structs?
Oh, like say you write in some config for a controller, and there's also like an object that is the controller itself, right?
Ah, okay.
Like that would be the runtime struct. So like the thing with like the run method hanging off of it for that kind of stuff. Sometimes there's like, you know, less complicated things. Like maybe you just have some data structure that is like a special has special methods on it. That's like not something we're set up to serialize to YAML. That would be like a runtime struct also. So I think some of these configs in here have runtime structs hanging off of them, like the completed config, or maybe this config. Like there's an event recorder on here that's a runtime struct.
This one here?
Yeah, there's REST clients on there. So like anything that's like an interface isn't serializable.
Okay.
So they have the component config in this config, and then they have all this other stuff that is runtime. So maybe complete has something to do with that, but I'm not 100% certain.
All right. Let's go back. So this is all applied to, and I guess at this point we have like a completed config, right, with all the necessary options and information we need. And I guess then at this point the controllers get started from that, right?
Yeah. You start a server, client builder. So they set up some other stuff here. I think that's common across the controllers.
Starting controllers here.
Yes.
Okay, at this point, I guess we're just starting things with the options. But like, as far as we are concerned, I mean, we should be like done like until the like completed config, right? Yeah.
Yes.
All right, let me check. I did have.
It's nice that those configs already embed the component config and plumb it all the way through. So a lot less plumbing here. Like Kubelet keeps the flags and configs separate and plumbs them both all the way through. And so when you move one from one to the other, you have to like go find the references and update the references.
Yeah.
Which is a real pain.
I remember the last time we spoke, you mentioned something that there were some, what was it? Some structs with missing group names. I couldn't find this again.
Oh, what was that?
I don't remember where you mentioned that.
Was that in the sort of component config substructures for all the subcontrollers? So like, let me look here. If I look at register.go for like package controller daemon config v1 alpha 1.
Yeah.
And then so there's no group name defined there. And if I look in kubelets register.go, there's a group name defined like kubelet.config.k8s.io. And that part of that is like each of these things is not in a real API group. These subcontrollers right now, they're just like pulled into the overall controller manager configuration.
Mm.
And then where was that controller manager configuration again?
This one here.
What file is that?
It's APIs config types.
Okay, let me get that up.
Package controller APIs config types. But this one is the is this the internal?
Yeah, this is the internal. But it still has a group name. kubecontrollermanager.config.k8s.io, like you'd expect.
Where's that?
So it's in both register.go files. So it's in both the internal and external. So
yeah. Here, yeah.
So,
okay.
So, and that's because this is like the top level thing, and right now it's all embedded in here.
Yeah.
I think the major question we got to answer is, do we just keep it that way, or do we split it out into multiple like sub objects? Where each controller has its own group. I think one thing that might be necessary if we split it out is to like define more formally the specification for what a controller manager is and what it provides to the subcontrollers. And then that gives you like, this is the generic controller manager configuration, right? Which is the first substructure here. Yeah.
No.
And maybe it's these things. Maybe this is what a controller manager provides. And this is like its own object. That's the generic thing for the controller manager. And maybe from that, you get all like the client's, authentication configuration, that kind of stuff. That's kind of the thing I want to figure out is like, if we split these out, we don't want to be retyping boilerplate on every single one for like authentication config. So we need some object outside the set of subcontrollers that serialize that contains that configuration. And I think that's kind of where all the argument stopped. Was early last year we kind of talked about this, and then there wasn't a decision and people moved on to other things.
I guess we'd have to look at, how much can be shared in what way, and what are like the pros and cons, right? Maybe just get this on one page and saying, okay, if we keep it together, I guess this is what was done here. Wasn't it like in the design document, which I think Lucas started, is what they tried to do? Like, what are the different alternatives here?
Yes.
Hmm. Another thing you said was we kind of like want to look at migrating it to V1 Beta 1, right? And find the issues which kind of block it or like prevent it to be serializable. Given this options struct, we have, what is it?
Yeah, what's in there that prevents us from serializing it?
Yeah, is there something like we can work with? Like as you said, like the abstractions are quite clear cut, I guess, in this case.
We don't need to serialize. We shouldn't need to serialize the option structs because those just hold the flag values that get read in, right? We should just need to be able to parse a cube control at minimal. If we don't even split anything up, we should just have to parse this cube controller manager configuration component config file. So is that serializable or not?
What do you mean? Sorry, I couldn't follow that one.
The one that is embedded in the config.
This one here, like control.
Yeah, that's the thing. The external type of this is what we should have to parse. And people had said that they were not, like you saw the issue, they said they weren't serializable. I want to know why.
Yeah.
Because this looks pretty serializable on the face of it. And maybe it's because the defaulting logic is no, because we saw the set defaults. That's there. So I don't know why. Maybe they just meant that the individual subcontrollers configurations were not serializable. Maybe it's referring to that and not the whole thing. So maybe it was only in relation to splitting things up, right? Because we saw that there's no group names in there, and maybe there's some other things that are lacking. So maybe that's all it applies to. And if we were going to use the big fat object, it wouldn't be a problem. But people were worried about that, so I want to know why. Yeah. Do you feel like you've got kind of a good picture of how things sit and kind of what to work on next?
Sorry, like this might be like a basic question, but do we need like an API group to serialize it?
Yes, because the scheme needs to find a registered GVK for the.
But I guess
reading in.
Like right now, if we would just keep it like in one big file, then the Cube controller manager config itself is, I guess, it has an API group, right? But all the subcontrollers would be like fields in it, so it was like this mega config file, right? In theory.
Yeah. Right. Yeah, in theory. So that's the question of like, do we want this mega config file or should we really split these apart? If you split them apart, then maybe there's, if you wanted to move certain controllers around into separate binaries or just like configure, replicas to just run a subset of controllers on each or something, then you could do that maybe more easily.
Okay, well, I guess what I want to do is look at this whole, like, is it serializable, right? Like, see, can we like serialize it as a big massive config, like as one file?
Start there. Yeah,
and see if that's possible, and if not, we'll just go from there, I guess. And if it's possible, then just maybe we can look at the pro and cons and see what would be necessary to split it up, and then start a discussion around that.
Yep, that sounds good. All right, cool. Tassine, if you had any questions, I want to give you a chance since Alex and I have been talking at the meeting.
Hi Mike, how are you?
Doing well. How are you? Happy New Year.
Happy New Year.
Yeah, so I wanted to ask a question about my PR about removing serialization of internal types in tests. Okay,
Sure.
so at first what I did was uh, directly decoding into one external type to another external type, but you said to first convert to internal type and then again to external type. So yes, I have updated the PR and did this. First, I have the YML. This is the external type, and I decoded it. Then it became the internal object, right? Yes. And then and the scheme has a convert method, and I used it to convert the internal object to the other external object. So is this correct?
Yeah, that sounds. I need to look at your most recent version of the PR. I saw the updates. I just haven't had a chance to review it yet. But that sounds correct. Yeah, like you want the. So if you're doing a round trip test for a given version, to make sure that the purpose of that test is to make sure that a conversion into and out of the internal type doesn't change any of the values that were set on that object. So if you convert, if you take like a v1 alpha 1 of some type, then convert it to the internal type, and then back to v1 alpha 1, they should match each other. And it may be, you may see like the YAML is textually different, but the values are the same. Like if your v1 alpha 1 had like,
default values are applied after conversion.
Sorry, say that again.
So default values are applied after. Yeah. So if I pass an empty v1 alpha 1 object and do the conversion, then the default values are applied.
Right. So you should be, the round trip should test like an already defaulted.
Okay.
Yeah.
Yeah. Thank you, man.
Yeah, you're welcome. Cool. Savita, do you have any questions? We got about 5 minutes.
Mike, nothing today. I'm just hanging out to learn something more.
Cool.
But probably next week I'll have some updates and something to share.
Awesome. Sounds good.
Great.
Great.
Thank you, Mike.
Yeah, you're welcome. Thank you. All right, folks. Does anyone have anything else? Okay, I think we're good. Great meeting, everyone. Thanks for coming.
Thanks a lot, Mike.
Yeah, see you all next week. Oh, one more thing, Alex. Keep an eye out. I remember Nancy said she was going to send like a maintainer track talk CFP for KCEU. So if we want to do a talk at EU, let's keep an eye out for that.
Okay, cool.
Don't miss a deadline.
Where's that being broadcasted? Is that on like the dev list or?
I'm not sure.
Yeah.
Nancy just said she would send an email to maintainers in January.
Okay.
I can ask her again.
Oh, we'll just probably just wait. We'll see it.
Yeah.
I'll keep it an eye. Yeah. Cool. All right.
All right. Sounds good. Thanks, everybody.
Cool. Thank you. Bye-bye.
Bye. Have a good one.
You too.
You too.